Just be a bit echoey, that's all. Hello, so we're starting the video by looking at identities, or trigonometric identities if you want the full fancy name. So there are three sets of identities here. The first one is called the Pythagorean identity, and you can test it on your calculator if you want to. If you take any value at all, like 3 pi or something like that, and if you go sine of 3 pi and square it, and then you go cos of 3 pi and square that and add them together, you will always get the value 1. Why does it work? Watch the video that I put on Google Classroom last lesson. Tan x equals sine x on cos x. I reckon you'd be already familiar with that one. Why does it work? Watch the video, you'll find out. But generally speaking, we have looked at this before, because if you remember that sine x is the y coordinate and cos x is the x coordinate, then really we're just looking at rise over run there for that particular identity. And then the bottom set are the new ones, which are called double angle identities. They're powerful because if you have a look at the left-hand side, you've got a double angle, and on the right-hand side, you've got a single angle. So you've in fact simplified the argument of the trig functions. Okay? So, I don't know, when would it be useful? When you're solving particular equations, you'll see it being used. But, you know, something's really quite simple like sine of 15 could be worked out because you know what the cosine of 30 is. Okay? So, or even easier here, you know what the cos of 60 is. So, if I put in sine of 15 here and put the cos of 30 here, then I could work out what the sine of 15 is by just adjusting the formula and working it out. Okay, so don't worry, you don't have to know how to do that now. I'm just trying to explain to you why it's useful. Anything which kind of deconstructs from a more complex argument to a simpler argument is considered to be something worth pursuing, really. So, this one here is the double identity for cosine. Cos 2x equals 1 minus 2 sine squared x. So remember that notation means that I take the value of the angle, work out the sine of it, and then square the result. And then in this particular context, then I will double that and take it away from 1. That's what that means. So BODMAS rules. This one here means 2 multiplied by, take the angle, take the cos of it, square the result, double it, subtract 1. 2 cos squared x minus 1. And the third one is cos squared x minus sine squared x. And this identity is the equivalent for sine. It's nice and simple. Sine of 2x equals 2 sine x cos x. And that's all there is to it. Understanding why they work is in the video that I posted to Google Classroom last lesson. I won't go through it now because you've already had an opportunity to watch it if you wanted to. Anyone watched it? Okay, just one person who watched half of it.
Yeah.
Okay, so that's the construction stuff. So number 6 here is just a really basic question, and I'll give you just a couple of moments to have a crack at it. So in this instance, you're told that sine theta equals 3/5, and that theta is an acute angle. It's between 0 and pi on 2, 90 degrees. So what your task is to work out what sine of 2 theta, cos of 2 theta, and tan of 2 theta is. You've actually got everything you could possibly need in order to solve that. Let's see how you go. I'll tell you one thing though, in terms of just getting started, maybe try question 2 first. Because you can actually directly work out what cos of 2 theta is, given that you know what sine theta is, whereas sine 2 theta actually requires a little bit more work. So I'll give you a moment to try it out and then I'll unpack it for you.
Does x count as theta? Yes.
Okay, let's have a look at the solution to number 2 first, to go out of order. So number 2 is cos 2 theta. Now, when you have a look at the different forms of the identity for cos 2x, we've got this one, and this one. But these bottom two require me to know what cos x is, which I don't know yet, or in this case cos theta. So cos of the variable. So these two are out, but I do know what sine theta is. It's 3/5, so I'm good to go here. And so I can say cos 2 theta is equal to 1 minus 2 multiplied by sine squared theta, which equals 1 minus 2 3/5 squared, which equals 1 minus, really spelling it out here, 9/25.
Oh, so you can put the square outside of that. I just kept the square.
Oh, I did some wrong calculations, that's why I got
Yeah, that's what I was like, what?
That's why I got
Tara, when did you get confused, just so I can spell it out?
I literally just put the 3/5 where theta is, and I just kept the square next to the sign, and I was like, what is going on?
Okay, so please, so the critical thing here is that it's a notation thing, right?
Yeah. In fact, you said it last time.
I did, I said it
Yeah.
multiple times.
Is it a common step that you just don't move it out where it needs to be?
There's lots of random stuff that happens. Okay, that's what I've got there on slide 8 is true for sine, it's true for cosine, it's true for tan. Okay, it's notation. It's because putting brackets around the whole of cos theta is deemed to be messy, particularly when you've got inside brackets as well. And so the notation is that the square goes between the function and theta. Remember that sine theta evaluates to 3/5, sine theta does. So that's notation. Get used to it, please. There's literally nothing else I can say to you except give you strategies for getting used to it, like sticking it on flashcards on your phone, or putting it at the back of the toilet door, or whatever else works for other things you just have to memorise. I don't think there's a constructivist way of looking at it, because it's just a matter of notation. Okay, 1 minus 2 times 9/25. So we're doubling 9/25. So that's going to be 9 plus another 9/25. So it's 18/25. The next thing I hope you can do in your head, 1 is 25/25. So 25 minus 18 is 7/25. And that's what cosine of 2 theta is.
Oh, that's it.
Any questions?
No.
Note that I did not need to work out what theta was. This is an absolutely legit paper 1 question. Okay, you do not need to work out what theta is in order to solve this. This is where you've got to get used to the idea that sine and cosine. Oh, it's a shame that none of that was recorded. Or is
It
it?
is, it is.
Oh, it is. Why is it still there then? Okay, cool. It's where people get confused now is where they start misunderstanding or misapplying the idea that 3/5 is the result of the sine of theta. Okay, it's the value. That's all that you have to worry about. The angle is not important because we're not asked at any point to work out what the angle is. Okay, so you don't do that. You simply utilize your identities to solve for the sine, cosine, and tan. Now, sine of 2 theta is a little bit more difficult to do because the only thing we've got for sine of 2 theta is that it's equal to 2 sine theta cosine theta, which we can't solve, right?
Yes.
Because we don't have this. So there's an intermediary step we have to do, and that's we have to find out what cos theta is. There's a couple of ways we can do it. So, yeah.
Question, didn't you only, for in this box 7, didn't you only work
wait,
out
wait,
what
sorry,
cos
Roshan.
2 theta is?
Didn't you only what?
Isn't 7/25 cos 2 theta? Don't we need to work out
That's-
what cos theta is?
That's what we just said.
No, so if you look at question 2, it says what is cos 2 theta?
Oh, yes, it does.
Yep. And so I'm saying that question 1, we don't have cos theta. We've got cos 2 theta, but that doesn't help us. because remember, cos 2 theta is, I've doubled the angle, what's the cosine of it? So you can't say cos theta would be, for example, half of 7/25, because that's not how it works. We're not halving the output, it's a different output. Does that kind of make sense? So there's a couple of ways you can do it. I'll show you though, which I think is pretty straightforward, but you might not. If you draw a little triangle, and you just arbitrarily make the bottom theta, then you're told that the sine of theta is 3/5, which means the opposite is 3, the hypotenuse must be 5, and some of you, a more astute of you, might recognise this as a 3, 4, 5 Pythagorean triple. So that means I've got 4 down here. Or you could use Pythagoras' theorem and go 5 squared minus 3 squared equals 16, square root it to get 4. So by finishing off the right angle triangle, you can say that cos theta is equal to adjacent over hypotenuse, so it's equal to 4/5. So that's way number 1. Way number 2 requires less thinking, a bit more calculation work, but you'll get there in the end. Okay? So if you have a look at the top Pythagorean identity, what's called the Pythagorean identity, the top trig identity in slide 5, you will see that sine squared x plus cos squared x is equal to 1. This is good news for us because we know what sine x is and we know what 1 is, so that leaves us with just one unknown. So we end up with 3/5 squared plus cos squared theta is equal to 1, which means that cos squared theta is equal to 1 minus 9/25, which equals 16/25. I'm just squishing it in a little bit so it fits in. So therefore, if I square root both sides, cos theta is equal to 4/5. It gets me there as well. Okay? So have a look at those two options there. Which one looks better to you? Which one do you think you'll be able to repeat?
Calculation work.
Option 2?
Option 2.
Option 2 for you? I don't care. I really don't. It's whichever way speaks to you. I will tend to do option 1 most of the time.
But you've got a master's, Richard. We don't have one. You've got a degree.
No.
2 degrees. A minor and a major, yeah?
We don't?
Yeah.
Okay. So I prefer option 1 because it probably reinforces the idea of a right angle triangle. But option 2, I do readily admit that students tend to go for it because they do like being a little bit of a formula monkey where they just put a formula down, put stuff in and get something out. Okay. So both are fine. Both are adequate. Okay. One undergraduate degree. One graduate diploma and 1 master's.
You've got certificate. Well, I was right about the masters.
Yeah.
Good guess.
Okay, so what about 10? Oh, I haven't finished this, sorry. So we've got 4/5 there. So what's the sine of 2 theta? The sine, I want to repeat it here, the sine of 2 theta is 2 sine theta cos theta. Now that I've worked them both out, I know that it's 2 times 3/5 times 4/5, wasn't it? Multiply out. 2 times 3 is 6. 6 times 4 is 24. So it's 24 over 25. Done. Now, hot tip for young players. If you do some calculations and the end result of sine, cos and tan is greater than 1, sorry, for sine and cos, tan's different. For sine and cos is greater than 1, you've done something wrong. Throw that to go, do not collect $200. Okay?
Is greater than or equal to 1 or just greater?
Can be equal to 1 and it can be equal to 0. So basically the value has to be between -1 and 1. Always. Tan can be anything, but sine and cos has to be between those two. Alright, let's do tan of 2 theta. All the heavy lifting has been done for us. Tan of 2 theta is going to be sine of 2 theta. I really should put brackets around when it's complex like that. Over cos of 2 theta. Now this is going to be fraction work, it's going to hurt, but you can do it. Sine of 2 theta. Can someone tell me so I don't have that?
24 over 25.
24 over 25? Thank you.
Then times 25 over 7. Or
Oh, but there, sorry, was it one?
7 over 25.
Hey, I recently saw this notation as well, which I quite like. And when the denominators are the same top and bottom, you can cancel out.
Oh,
Oh, it's on.
maybe I do. I don't know.
Well, the problem is that it looks a bit too magical, right?
Yeah.
It magically works. The reason why it works is because remember that big bar in the middle here, that big bar converts it into a multiplier by the flip. So that becomes 25 over 7. So the 25s cancel out, and there's the 7 underneath. That's why it works, but it is a bit mathematical. Julie, to right, yeah. I would not change it from there. I would not waste another 30 seconds working out how many times 7 goes into 24, 3, and the remainder 3, and then writing down 3 3/7. You will not lose any marks, and I don't even think it's poor communication because improper fractions are okay as well. Okay, all good to go. Alrighty, what I'd like to do now is we've got 10 minutes left in this lesson, so I'm going to get you to go to exercise 13E, and you're basically just going to practice the same ideas here for the next 10 minutes, and then on Thursday's lesson, we're going to have a look at more complex equations. So a bunch of you are going to have a bit of homework to do between now and Thursday if you haven't already done it. And I am kidding you not, if I don't see complete homework from each student, those students who have not got that homework complete will be asked to attend the Friday afternoon session, catch-up session. End of.
That would make me cry.
No, we don't, unless you've done homework, so you don't for it, but
I just came back from lunch. It takes me a while to understand.
I think I'll just do question 2 and then question 5 to 7. And I'm going to say it here and I'm not going to say it on Google Classroom. These questions have to be completed for homework in addition to the other homework, start now, in addition to the other homework if you have not yet completed it.